In this tutorial, we will make use of the AreaOnAreaOverlayer Transformer. We will explore how FME can be used to overlay two or more polygons to determine and extract the area in which they overlap. Let's look at our data using the FME Data Inspector. We will make use of zoning data stored in MapInfo tab format. That includes attributes for zone category. We will also use neighborhood data stored in Google KML format that is tagged with the neighborhood name attribute. For our exercise, we will determine the percentage of land in the Kitsilano neighborhood that is zoned for commercial use. The workspace will measure the neighborhood area, overlay it against the commercial zones, and calculate the area of the data extracted. Open FME Workbench and create a new workspace. Add a MapInfo tab reader and select the zone's dataset. Add a Google KML reader and select the neighborhood's KML dataset. When prompted, select only the neighborhood's layer. Add two tester transformers. Connect one to zones and the second to neighborhoods. For the tester connected to zones, open its parameters and set it to test where zone category equals commercial. For the tester connected to neighborhoods, open its parameters and set it to test where neighborhood name equals Kitsilano. Let's also add a reprojector to the canvas and attach it to the neighborhood tester passed port. This is necessary because the neighborhood data is stored as latitude-longitude. Since our zoning data is UTM 83-10, this transformer will reproject them to a common coordinate system. Add an AreaOnAreaOverlayer and connect it to the tester and reprojector. Attach an inspector transformer and run the translation. Inspect the output features. You will notice a newly created attribute called Overlaps. Let's revise our workspace so that we can clearly see the polygons where an intersection occurs. Add another tester between the AreaOnAreaOverlayer and inspector transformers. Set it to test for where overlaps are greater than 1. A number of 2 or higher denotes an intersection of multiple polygons. Go ahead and run the workspace again. The result will be polygons that show only the intersection of the Kitsilano neighborhood with commercial use zoning. But we can continue to improve our workspace by including some additional steps. Let's calculate the area of intersected polygons as a percentage of the entire Kitsilano neighborhood. To do this, add an area calculator transformer to the canvas. Make sure to place the area calculator after the reprojector, or else its measurement units will be calculated in decimal degrees. Set it to store the area of the neighborhood in an attribute called Kitsilano Area. Add another area calculator transformer after tester 3 to calculate the area of the intersections. Set it to store the area of these features in an attribute called Intersected Area. Add a statistics calculator transformer and connect it to our second area calculator. Drag and drop the connector from the summary output port to the complete output port. Open the parameters and set it to analyze the intersected area attribute. Delete all of the attributes to be calculated, except for the sum attribute. Write the sum to an attribute called Total Intersected Area. Finally, add an expression evaluator transformer behind the statistics calculator. Open the parameters dialog and set it up to calculate total intersected area as a percentage of the original Kitsilano area. Go ahead and run the translation again. The output will include new attribute fields for intersected area, total intersected area, and result. You will see that 11.8% of the land in Kitsilano neighborhood is zoned for commercial use.